This tutorial will illustrate how a moving vehicle can dynamically excite a bridge. We will run an HS20-44 truck at 3 different speeds to see the different responses. Our composite bridge is 2 spans, each with a length of 100 feet. It is 36 feet wide, constructed with steel girders, cross bracing, and a concrete deck. It has 2 12-foot lanes, but we will only load lane 1. We start by defining our truck. When using a vehicle load for a dynamic analysis, it is important to use a truck load and not a lane load. We next add our vehicle to a vehicle class. Now we will define our moving load case, which we will call truck. Clicking on the Modify Moving Load button allows us to specify how the trucks will run over the bridge. Here we can specify the vehicle, the lane, the start time, which for the first truck will be 0, and the speed, which will be 75 feet per second for the first truck. For the second truck, the start time will be 6 seconds, and the speed will double to 150 feet per second. For the third and last truck, the start time will be 11 seconds, with a speed of 300 feet per second. We are using speeds higher than typical to cause a significant excitation of the bridge. We will use a 15-second duration for the load and a 0.05 second step. The last step is to modify the analysis case. Note that a default case for truck was created as a multi-step static case. We will change this to a time history analysis so that the dynamic behavior will be included. We will leave it as a linear analysis, but change the time history type to direct integration. The program automatically creates a default load application using a ramp function to apply the truck loads, which we will not change. We will ask for 320 time steps and a step size of 0.05 seconds. We are now ready to run the analysis. Note that the truck analysis case is now a dynamic case. We will shut off the modal case as we do not need any mode shapes for our analysis. With the analysis complete, we can display the deformed shape. In this case, we will show the shape at 1/2 second into the analysis. However, the dynamic effects of the vehicle loading can best be seen by creating a movie. Here, we will create a movie for the truck analysis case. And we want to make sure that the trucks are shown in the animation. When we play the movie, we see that the first truck has a limited dynamic effect on the bridge. And the second truck just slightly more. However, the third truck causes significant excitation of the first mode of the bridge. Once again, the first truck at 75 feet per second, the second truck at 150 feet per second, and the third truck at 300 feet per second. In conclusion, bridge structures may be sensitive to the dynamic effects imparted by moving vehicles, and SAP 2000 offers a powerful and easy way to include and view these behaviors. This ends this tutorial.